Our planet is a gallery of wonders. It holds landscapes of breathtaking scale and serene beauty, towering mountains scraping the sky, deep oceans cradling mysteries yet unknown. But there are places on this earth that defy our very understanding of what a landscape can be. They seem not of this world, but of another, more fantastical one. One such place is the Dallol Depression in Ethiopia. It is a masterpiece of geological art, a canvas painted not with a brush, but with the raw, elemental forces of the earth itself. Here, nature has sculpted a scene so bizarre, so vibrant, and so utterly alien, that to witness it is to question what you know about the world we call home. Imagine stepping onto the surface of another planet. The ground beneath your feet is not soil or sand, but a brittle crust of salt and minerals. The air is thick with the scent of sulfur, a primal aroma that speaks of the planet's fiery heart. All around you, the landscape erupts in a riot of impossible colors. This is Dallol. To find this otherworldly landscape, we must travel to one of the most extreme regions on the globe. Dallol is nestled within the larger Geological Depression, in the Afar region of northeastern Ethiopia. This is a land of superlatives. It is part of the Great Rift Valley, a massive geological scar where the African continent is slowly tearing itself apart. Tectonic plates are pulling away from each other, thinning the Earth's crust, allowing the molten mantle below to press ever closer to the surface. This immense geological activity is the engine that drives the creation of Dallol, making it one of the most volcanically active places on the planet. The location itself contributes to its extreme nature. The Dallol Depression sits at a staggering 130 meters or 430 feet below sea level. This sunken geography traps the heat, creating a furnace-like environment. The sun beats down with an unforgiving intensity. The air itself feels heavy, thick with heat and humidity that clings to you. This region holds the record for the highest average temperature for an inhabited place on Earth. Annual average temperatures soar to over 34 degrees Celsius. The combination of this intense heat and the low elevation makes the Geological Depression one of the most inhospitable environments imaginable, a true test of endurance for any form of life that dares to exist here. The first glimpse of Dallol is an assault on the senses. After the muted browns and grays of the surrounding desert, the sudden explosion of color is almost unbelievable. It looks as if a giant has spilled pots of paint across the landscape. The dominant color is a startling sulfur yellow, forming vast fields and strange, conical mounds that rise from the salt flats. This yellow is created by the sulfur that is carried to the surface by the hot springs. As the water evaporates, the sulfur crystallizes, painting the ground in brilliant, shocking hues that seem to glow under the intense sun. Interspersed with the yellow are pools of acid that shimmer with an ethereal green light. These are not watering holes for thirsty animals. They are highly corrosive ponds, their color derived from dissolved iron and other minerals in the superheated brine. The water bubbles and hisses, releasing plumes of steam that carry the sharp scent of sulfur and chlorine into the air. The edges of these pools are often encrusted with delicate crystalline formations of white, orange, and red, creating a filigree of mineral lace around the bubbling cauldrons. It is a scene of both breathtaking beauty and palpable danger. It is a symphony of color and steam, conducted by the immense geothermal forces of our world. The environment at Dallol presents one of the most profound challenges to life anywhere on Earth. Extreme heat, high salinity, and intense acidity creates conditions that were once thought to be completely sterile. For a long time, scientists believed that no living thing could possibly survive in the bubbling, toxic pools. The water here can be more acidic than battery acid. The salt concentrations are so high they would desiccate any normal cell almost instantly. It is an environment that seems purpose-built to destroy life as we know it. And yet, life is tenacious. Recent scientific explorations have begun to challenge this assumption. In the less extreme parts of the Dallol system, where temperatures and acidity are slightly lower, researchers have discovered evidence of microbial life. These are not animals or plants, but extremophiles, microscopic organisms. They are a form of life that exists on the very fringe of possibility. Their discovery here has profound implications for our search for life elsewhere. These microbes are called polyextremophiles. They tolerate multiple stressors. If life can hold on in Dallol's boiling brine, it raises the possibility of similar organisms on other worlds. That contrast, hidden microbes versus visible emptiness, makes Dallol a natural laboratory on the edge of life. While the heart of Dallol is just way too hostile for settlement, the surrounding Dallol Depression has actually been home to the Afar people for centuries. They're a semi-nomadic community of pastoralists and warriors, and over time, they've developed an incredible resilience to this unforgiving environment. Their culture and livelihood are, deeply intertwined with the desert and its most valuable resource, salt. For generations, the Afar have been the guardians of the vast salt flats that stretch out from the colorful hydrothermal fields. This salt, which was once so valuable it was known as white gold, has been the cornerstone of their economy and a central part of their identity. The Afar's traditional work is honestly one of the toughest jobs on Earth. Under the searing sun, men work in teams, using pretty rudimentary axes and poles to pry large slabs of salt from the ground. They cut these slabs into uniform rectangular tiles called a mole. Once the salt tiles are cut, they're loaded onto the backs of camels and donkeys. This marks the beginning of one of the world's last great camel caravans. Hundreds of camels, sometimes stretching for over a kilometer, begin the long and arduous journey from the depths of the Dallol Depression up into the Ethiopian highlands. The trek can take days or even weeks, crossing a harsh and dangerous landscape. The Afar and their timeless relationship with the salt of the Dallol remain a vital part of this extraordinary region's story. Dallol is more than just a place of stark beauty. It is a site of immense scientific importance. Geologists, chemists, and astrobiologists flock to this remote corner of Ethiopia because it offers a unique window into processes that are rare on Earth's surface, but may be common on other planets. The hydrothermal system at Dallol is what is known as a subaerial system, meaning it is exposed to the air, which is unusual. This allows scientists to directly observe the complex chemical interactions that occur when superheated, mineral-laden water from deep within the Earth meets the atmosphere. For geologists, Dallol is a living textbook. The intricate mineral deposits provide clues about how ore bodies and other valuable mineral formations are created. By studying the way different compounds precipitate out of the hot brine, scientists can better understand the formation of deposits of salt, potash, and sulfur in other parts of the world. The entire area is a dynamic laboratory where the processes of mineralogy and geochemistry are happening in real time, not over geological timescales of millions of years. Perhaps the most exciting field of study at Dallol is astrobiology, the search for life beyond Earth. The extreme conditions here serve as an analog for environments that might exist on other celestial bodies. For instance, the early history of Mars may have included similar acidic, saline, and volcanic conditions. By studying the extremophile microbes that may exist in Dallol's pools, scientists can learn what kind of biosignatures, or signs of life, to look for when exploring the Martian surface with rovers. This makes Dallol not just a location on a map, but a frontier of human knowledge, pushing us closer to answering some of science's most profound questions. To truly understand Dallol, one must imagine being there, experiencing it with every sense. The journey begins with the feeling of intense, dry heat pressing in from all sides, a physical weight on your shoulders. The air is still and heavy. The silence of the desert is broken only by the crunch of your own footsteps on the brittle salt crust. As you approach the hydrothermal fields, the air changes. It becomes thick with moisture and a sharp, acrid smell, the unmistakable scent of sulfur. Visually, it is overwhelming. The colors are more vivid than any photograph can capture. Yellows are fluorescent, greens are like liquid emeralds, oranges and reds burn with an inner fire. These colors shift with light and flowing water. Steam rises in shimmering veils, distorting the landscape. Mineral towers appear to dance and sway. It feels like a dream, beautiful and menacing. The sounds of Dallol are subtle but constant. Gentle hiss of steam from fumaroles, soft bubbling and gurgling from acidic pools, occasional louder gushes or sudden steam releases. A reminder the ground is a thin crust over immense energy. You can feel the heat radiating up through the soles of your shoes. A landscape of contradictions that imprints itself on your memory long after you have left. Dallol holds a significance that extends far beyond its strange and beautiful appearance. Its importance can be understood on multiple levels, for the planet, for science, and for the human spirit. Ecologically, it is a showcase for the extreme limits of life. The discovery of microbes thriving in such a hostile environment has fundamentally altered our understanding of biology. These organisms represent a unique and precious form of biodiversity, a genetic library of survival strategies that could hold untold secrets, perhaps even for applications in medicine or biotechnology. For Ethiopia, Dallol and the wider Dallol Depression represent a natural heritage of global significance. As tourism to the region grows, it offers a potential source of economic development for the local Afar communities and the country as a whole. However, this brings with it a profound responsibility. The mineral formations at Dallol are incredibly fragile. Balancing the desire to share this wonder with the world and the need to protect it from harm is a critical challenge for the future. Sustainable tourism practices are essential to ensure that Dallol remains pristine for generations to come. The scientific value of Dallol as a natural laboratory for geology and astrobiology cannot be overstated. It is one of the few places on Earth where we can directly observe the kinds of processes that may have shaped other planets. As we send rovers to Mars and plan missions to icy moons, the data gathered at Dallol provides a crucial ground truth. Its protection is not just a matter of conservation. It is a matter of preserving a vital key to understanding our place in the cosmos. Ultimately, the importance of Dallol lies in its power to inspire wonder. In an age where we often feel disconnected from the natural world, places like this serve as a powerful reminder of the planet's wildness, creativity, and mystery. Dallol is a treasure, a fragile, brilliant jewel in the crown of our planet's natural wonders.